Today we're going to take you through, without any further ado, hybrid connectivity. And first we're going to talk a little bit about why this is a really immediate challenge and how the stage is becoming more complex each day for the IT and network operations professionals that have to manage it. You can see from the chart, no surprise, 2/3 of enterprises are now using SD WAN. But more importantly, these are SD WANs that are primarily served by internet-based underlays. So a lot less assured and no SLAs typically for a lot of the network transport that's happening underneath. You can see that SD WAN is growing at a dramatic rate at the expense of MPLS, which is still quite popular and used for critical links, but SD WAN is starting to prove itself as a worthy replacement. We'll talk about what we need to do to make sure that kind of hybrid connectivity as well. With workers telecommuting, working from home, moving hybrid from the office to other locations on site, you start to have a lot of different types of connectivity we'll talk about, including, of course, the internet providers that people have chosen for themselves. And also another part of the equation is that as people move more remote and the activities and applications that people are accessing become more cloud-based, the security perimeter is changing. It's becoming much more dynamic, and it really has to follow the user and their device. And we'll see that kind of trends along with the SD WAN. So 2/3 of enterprises planning to have that deployed by the end of next year, and quite a rapid adoption rate there. Making things a little bit more complicated in terms of connectivity, it's not just really the user connecting to an application or a cloud, or even a cloud to a cloud. It's also applications interconnecting with each other, which we'd call a composable application. So today, 3/4 of the applications that are used in an enterprise are actually interconnecting with a number of other applications. And 80% of those or more are actually hosted on the cloud or are SaaS applications that are really not hosted at all within the enterprise's IT department's own infrastructure. It's becoming quite obvious that the network itself is becoming really the critical backplane of connecting all these applications to their users. And you can see from some data we've pulled from the Kadiska platform that if we look at a web-based application, the network in many cases is actually the dominant factor for the latency that the user is experiencing. There's many other factors in there, but the network is also influenced by different forms of infrastructure like the CASB that we talked about, DNS performance, and other methods that determine the path through the network. We're also seeing, of course, that we're going to be soon approaching a majority of traffic from enterprises not going to private locations or inside the LAN, but actually going to SaaS and cloud applications. And as the traffic starts to leave the more private networks that the enterprise and network operations teams are used to, we're also seeing from their surveys with these professionals that they don't feel they adequately have the ability to monitor the networks that are serving these locations. So really a strong trend here where the network is becoming more vital. More of the traffic is going to locations outside of private premises, and at the same time, there's a lack of visibility that would help these teams actually assure their performance.
The main thing to explain is what is hybrid connectivity in the end, and to which context does it apply? And when you look at the simplified topology of an enterprise that has hybrid IT in place and has moved some of its workload to SaaS, cloud through IaaS or through platform as a service, you've got 7 items that you can map. So on the left of that diagram, you can easily see the old part of your network estate, which is on-premise sites connected to our data centers through an MPLS. And on the right side, you see the new parts. On the hosting side, SaaS, multiple cloud providers, and in between the user locations and those workloads, a series of public networks, which actually serve as an underlay for SD-WAN, for the CASB communication, for the VPN, which allow the distributed users to make it to their different workloads. So the people sitting on-prem that might connect to cloud and SaaS, the VPN, the branches, and the people working from home. So you see the breadth of the change by how complex that diagram moved from something that was radically simple before, and where the number of service providers involved were really small. If we go one, it's cloud to cloud. If you use multiple cloud provider, you will need to establish connectivity between the two and control the quality of it. Cloud things got, insisted, on composable applications. One of the main combination in composable applications is, for example, connecting through APIs, SaaS applications like CRM and ERPs to other applications that are going to present business data, for example, to partners and customers. Another one is connecting cloud and SaaS to the data center. Of course, every time people start the cloud migration, they can migrate everything, and there is always some workload remaining in the data center, and those workloads need to communicate with the SaaS and cloud platforms, which means it's another part of the connectivity that needs to be assured somehow. And finally, if we move to the user connectivity, users sitting on-prem, they're going to connect to the data center, not always through MPLS, but through an SD WAN connection, for example, but they will also connect to SaaS and cloud provider, eventually through a CASB, so a solution like a Zscaler or a Netscope, or you might call it a secured web gateway, but that's another element of complexity. The people from the branch will use the SD WAN for that, and the people working from home will connect either through VPN, direct, or through CASBs to a set of internal and SaaS applications. So you understand that with hybrid connectivity, it's the complexity of the overall system that is exploding. Okay, but there is more to that as a challenge from a visibility and observability standpoint. Hybrid connectivity brings in new elements that make the job of IT teams far more complex. And I'll take you through 3 layers, from where we host applications to the network that sit in between users and applications. If you look at the hosting part, the first thing is, one, you don't have access to the infrastructure layer on which those applications are hosted when you start using SaaS applications and PaaS applications, or you start using microservices. So it's far more complicated to instrument those parts. That's number one. Number two is those applications by nature are far more distributed. In the early days, we had a simplistic view of SaaS, for example, where users would connect through the internet to one location where the SaaS platform would be. The reality is actually far different from that. When you connect to a SaaS platform, you connect to 20 or 30 host names, and each host name actually takes you to a different place depending on where you connect from, which operator, from which location in the world. The resulting matrix is far more complex, and for example, capturing traffic on things like that is almost like impossible. And there is a second layer of complexity and challenges that come from the evolution of the network. How we go through the network. We go through a strong encryption when we connect to those services. You probably heard of perfect forward secrecy, which brings in new encryption schemes that are almost impossible to decrypt. And that takes away some ability from anything that relied on traffic analysis to monitor performance. So that's one. The second one is the appearance of zero trust networks and CASBs. Well, they bring in more complexity because every time you connect to a CASB, you go through a DNS resolution, you are redirected to a node that is dynamic. The path you're taking to that CASB node can also be dynamic and change through time. And of course, from the CASB to the actual workload, you've got the exact same system. So DNS, redirection, public networks, and that makes the understanding the connectivity between the end-to-end connectivity between the user and the workload far more complex. And finally, sometimes we simply put an overlay like an SD WAN on top of the public connectivity, but while we had a certain doses of dynamic behavior with the SD WAN, the underlay connectivity is also dynamic, can change paths, can change the location through different resolutions. And if you monitor only the overlay, there are good chances that you do not understand why the performance of that overlay changes if you don't have control on the underlay. And finally, the users. The users are distributed, and each user is also having multiple locations to work from. People work from the office, people work from anywhere, they travel, they work from home, they use multiple sets of connectivity to do that. And that's also a challenge for IT, because supporting users and making sure they work efficiently from all of those places brings a new set of challenges, and the performance rate that were acceptable before when working from home was an exception are no longer acceptable these days, and the lack of visibility we had on that part of the user access is unacceptable these days. So that's for the challenges that hybrid connectivity brings in. And the outcome of that is that the traditional solution we've put in place for network traffic analysis in the data center times cannot really make the move to that new environment and provide a solution to it. And it is true when you are migrating. So if we take it as an example, an SD WAN migration, when you move to SD WAN from MPLS, eventually with some internet breakout, there's the first thing you probably want to do is having a baseline of how all your sites connect to different places, to the data center, but also to the SaaS and cloud through the internet breakout. You already start losing visibility to the encryption on anything that goes towards the internet or SaaS or cloud platform. But when you plan on migration, you probably want to know what is the original baseline. So what are the response times that my current users are getting? So that once you introduce SD-WAN as a solution to reduce the cost and increase the performance levels or drop the response time for your users, you probably want to know exactly what changes, where problems occur, how you can fine-tune your SD-WAN configuration to minimize the latency to the different workloads you connect to. So your data center, legacy applications, your SaaS, and your cloud. And because you use multiple underlays, you probably need to have some form of measurement to understand what is the best underlay to reach this or that destination, not always through an SD-WAN tunnel, but through a simple internet breakout. And if you don't have that feedback, there's no chance you're going to be able to optimize it. And so that's going to be instrumental to get that visibility through the migration to that new kind of connectivity. I guess the first thing in the cloud world is understanding that you're not getting to one destination. You're trying to resolve multiple host names to reach a SaaS, a cloud, a CASB. That applies to everything. And on that host name, you get an IP address, and that IP address is going to change through time. That IP address is going to change depending on your ISP. It's going to change depending on your location, and that's going to be dynamic. So the first thing you need to understand is whether that redirection takes you to a place which is narrow enough to provide the good latency or far from where you are. So if I take examples, I remember people at Airbus, for example, having trouble with their CASB and their Indian users, depending on the ISP, being redirected not to the Indian node of the CASB, but being redirected to the West Coast and then trying to make their way to Europe. There's no network problem in that. Actually, the network works as expected. It's just that the path is very long.
Yeah.
And the resulting experience is dreadful. So that's number one. The second one is the ISP performance and the BGP routing. So it's all about what is the quality of the connectivity that my ISP is going to provide to that destination. What is the route that I'm going to be taking? And that's driven by BGP, the protocol that drives how internet flows are routed through public networks. And here you can find plenty of different consequences. Either the path can be abnormally wrong or non-optimal. You might find that some devices on the way are not performing as expected, and that can result in a bad path, some additional latency or added packet loss on the way, which is going to penalize any application going through that route. Okay. The third one is CASBs and cloud proxies. You've got to think of CASBs as an additional node on the path, but CASBs have all the bad characteristics of any cloud or SaaS platform. They redirect you to a place. That place might be the right one, might be the wrong one, and they have a processing time, so they might have delay on the way. And it's important when you choose a CASB solution to understand whether their capillarity, so how distributed they are, offers the right service for all of your users, depending on where they are located, which ISP they use, and so on. And I guess it's very important to measure that, because you might find that some CASBs do not have a good coverage of a certain region, actually have a longer latency from your users to their nodes, or simply have a much slower processing. And all three reasons will have very, very big latency, additional impact, or added latency. The fourth one is SD-WAN underlay path changes. When you use SD-WAN, okay, you can switch from one underlay to another. That has an impact, but each underlay has got its own behavior and can change paths on the way, and that can drive to packet loss, that can drive to bad paths.
I've got a question for you here that came in, Boris. So this one is from an enterprise who was recently affected by the outage in Canada with the Rogers backbone, or they think they were. So what they said is they have two ISPs they're using in most locations on their SD-WAN. And the recent outage from Rogers really prevented them from connecting to a lot of their manufacturing sites. The question is, how can we determine if the two ISPs we have are actually physically redundant, or actually they're sharing some of the same network along the way?
Testing the path through the two ISPs will give you a definite answer. I can show you some live demo around that.
That would be a good one to demonstrate, I think.
We'll keep that for the last minute.
Sure.
But yeah, we've seen that. And what they think is plausible. Is it what happened? They just have to find out. And again, it's back to data.
Yeah, it's all about visibility in this case.
Application, CDN, load balancing, when you connect to cloud or CDN, they have their own logic. and dynamic behavior. They redirect to a point depending on load, depending on the state of their application, depending on the maintenance and so on. So that also has an impact. So for example, you might be taken to pretty quickly, but then inside Azure, you might find that you have a short pass inside the Azure network or a long pass to the Azure network, depending on where you are going to be redirected. And the same thing applies to CDN. SaaS platforms that you use are going to use CDN networks in principle to make the content close to your users, but sometimes it just doesn't work as expected and you might end up having a long pass to a CDN, and that will have an impact. The sixth one, we've got to remember that although we go through the internet, the local networks also have a huge impact and have their own issues, and Wi-Fi is one of them. And we find that sometimes the Wi-Fi coverage is just not right. Sometimes it just doesn't work as expected, and it's important to identify that this might be the cause of a bad experience for your users. And the final one is cloud network path length. So again, a cloud is just not one hope. I'm in the cloud, next hope, I reach my application. You might find that sometimes you've got 10 nodes on the way, and sometimes you may just go across the pond through the cloud network. Right, so what is required to be on top of your hybrid network performance? I guess the first thing is understanding what is the full path visibility. So what is the path that my users or my traffic between application nodes is taking through public and hybrid networks? The second one is definitely SD-WAN. Having in mind having SD-WAN visibility is not just knowing what is the latency through the overlay, which tells you what is how intense the pain is, but doesn't tell you why and how to fix it. So you definitely need to look into the underlay to be on top of it and to be able to fix your potential issues and optimize performance. End-to-end is good, but hope latency really tells you where your problem is and how to fix it. So that's a very important thing. Very often we took the habit of just measuring latency end-to-end. Because we go across multiple operators, there are multiple vendors, and sometimes we go across not only a series of public networks, but there is one public network and then a CASB and then another set of public networks. So you've got to understand where the problem is happening. If it's on your SaaS platform, if it's through the internet on service providers you don't have any relationship with, if it's on your CASB, if it's on your own service provider, that could redirect the flow in a different way to be able to take a decision. So hope by hope is key to have good chances to be able to action a problem or optimize things. You need an historical perspective. Why? Because if I give you a snapshot of what connectivity is, there's no chance you're going to be able to tell, is it really the source of my problem? Is it something that got degraded? You won't be able to draw a conclusion if you don't have a good baseline. And that's true for many performance cases, but in this case, it's even more true. BGP AES routes. So if you're not familiar with BGP, it's a protocol that drives the routing through public networks, and autonomous systems are the domain of each operator in which they do their own routing. When you go through BGP, you decide what is the series of autonomous system you go through to reach a certain destination. That drives all the performance through the internet, from users to SaaS and cloud. So that's key to understanding exactly whether good connectivity is going to be the basis for a good experience or not. And finally, we do all that to stay on top of the experience for your real users and your real business activities. So what we think at Kadiska is definitely that what is the outcome to be measured is real user performance. So our view is that you need to know what is the impact of latency on your users' experience. I'll tell you in 1 minute how it's deployed. So you see the same diagram. You just see the Kadiska platform on the left, which is going to receive data and provide you with access to that data through alerts and dashboards, etc. The first element in what we do is a station. An enterprise station of Kadiska is a container that you can deploy. It can be deployed multiple formats in a VM, in the hardware, in the VNF of one of your switches or SD-WAN devices, the hardware on the system itself. And what a station is going to do is discover the path that you're taking to reach the different workloads or destinations that are important to your IT, and measure the end-to-end connectivity, and then break down that connectivity into hop by hop segment to understand exactly what's the contribution of each segment and where problems come from. Okay. Then we've got a second version of that, which are the managed stations. So managed stations are provided by Kadiska as a service from a few hundred broadband operators in the world and locations in the world. And here, the principle is that you can use those without any deployment so that you have a view from broadband users that the broadband providers that your work remote users might be using without having to deploy anything. And finally, when it comes to monitoring experience, we've got an extension. So it's an extension that sits on the browser of your users and track all the real usage they have of your applications and all the response times they have to isolate what's the part of the network, what's the part of the server processing from the SaaS and cloud platforms, and tell you exactly where to look when they complain about poor experience. And that has no impact on the browser, that has no touch to the operating system, so no security or maintenance impact. Okay, so that's how it's deployed. I guess the best thing we could do, move away from the slides and show you briefly what it looks like in the real world. So let me just move to our platform and I'll show you exactly the kind of data you can see quickly. So we use all the applications that the team is using, both internal and SaaS. Number of users connected to those applications, you see how much time they spend on it. You can flag right away the ones where you've got a connectivity issue. You can flag the ones that have poor experience, either for traditional applications that consist of pages, and for more modern applications, what is the time to process an API call? And you see the breakdown of that between the redirects, so the proxy, the browser, the network, the server, and the transfers. Okay, Google Docs was slow. It was a transfer issue, so it's related to how many people. And then you can put all of that in the context of where users are and what connectivity they use. So you can see that through time, but you can see that for remote users and see which operator they use, where they are located, and also see on-site users and understand people on the different sites, understand what connectivity they get and what is the experience they get, and what is making that experience not so good, if it's the network or if it's something else. And you can map that in that way. Understanding people from a certain site, going through a gateway, accessing the different applications and where they've got poor experience or latency, like for the SNAP platform, for example. And you can make that down to a single user, filter that, and troubleshoot it. So just for the sake of that example, if you want to see my week of work, you can see all the applications I've used, which ones were good, which ones were bad, where I had good latency, when I had trouble, like here, which ISPs I've used, where I've been, and what is the resulting experience of all those contexts. Okay, so if I pick a time very quickly, you'll see, okay, at that time, I had a problem with Google Docs and it took 15 milliseconds, and I could go down to every page and show you exactly, okay, this is why it was slow, and that's exactly how it got loaded onto my browser.
So Boris, just quickly, there's a question here. It says, what kind of agent do you need to deploy, and does it support like Linux and Mac OS or just Windows?
Oh yeah, it works cross-platform because it's not installed. It's not installed in the operating system. It's installed inside the browser, and that's why the CPU and RAM cost is close to zero. And it works on any platform you can think of. You could do that on a BSD if you wanted. That would work.
Oh, so it's good for people with Chromebooks too.
Oh yeah, no problem. Chromebooks is an easy one. Okay, and if you want to understand the connectivity aspects of that, so I'll take an example, for example, typical common SaaS platform, Salesforce. So you can see right away, okay, where is Salesforce really well accessible for my people and where it's not. The first thing is that one of their hostname has got a tremendously bad connectivity, like half second, and the rest looks fine, so we can focus on the bad ones. And we can see where from that's going to be not so accessible. And funnily enough, the thing we can see if I extract, I see a lot of packet loss in the northeast of North America. Does it ring a bell? I think you mentioned that in the question.
With Salesforce, I think there's always good days.
Well,
and some days where it gets a little overloaded, right?
Yeah, I wouldn't take it that way. It got very degraded, for example, for Brazil.
Yeah.
But, Canada. Does it ring a bell this time?
Yeah,
huge packet loss.
Yeah.
So let's focus on Canada. You see, 26% packet loss, 10%, 16%. So that's something that would forbid users from accessing their applications in a normal way. And
this is all about route diversity as well, right? Even if this is related to the Rogers outage, it might not be that you're on Rogers, but all the traffic is being redirected over other ISPs and through the autonomous systems.
Loss has been lasting for the whole last week.
Yeah.
In huge variations in latency. See the blue curve for Toronto, for example. We move from 30 seconds back to 13 milliseconds, back to 30 seconds.
Yeah, these problems are still ongoing. I can definitely confirm.
And if you want to know where they happen, underneath that, we see the corresponding route. And on the left, you've got the stations. On the right, you've got the different hostname resolutions, so IP addresses for the same hostname. So not all the people are redirected to the same place. And each cycle is actually a router from a given operator, and each color corresponds to an operator. And we see massive amounts of loss, for example, on data communication. We see massive amount of loss on nodes of ZIO. And that could well look like those networks were not designed to cope with the traffic that normally goes through routers. And if you want to understand when route is good, what is the path which is taken, you just select that in the graph and you understand what is the route which is taken and where people go to. And when it's getting bad, what is the change? You get to see that they are redirected to another point and they don't take the same path and they suffer from even more latency.
Thanks everyone for joining us.
Thank you.